Hello, my name's Daryl Korn, and this is my voiceover for Homework 1. So I will start with going over my blocks of code. So here is my movie reviews code. Here we are inputting our user data. So we select 4K folds. We can select how many epics we want. We can select how many words we want in our training data here. We can select our learning rate, and we can select how many hidden layers we want in our network. Here we are downloading the IMDb data as well as splitting it into training and test data. Here we define two functions, the vectorized sequences, which takes the training data and test data, and instead of a list of integers, it's going to be um, vectors instead, which is better. It's more useful for our networks. Similarly, the build model creates our model based on how many words we have in the training data, how many hidden layers we want. I just have an if else statement based on the user input, and we can set our learning rate. So we have a sequential model. We choose how many hidden layers we want to add, and then we compile our model. And we are using RMS prop for the optimizer, binary cross entropy for the loss, and then binary accuracy for the metric. Here, we actually run all of our tests. So we have an outer for loop to test different sizes of epics. Then when we go into processing each of our folds here, first we vectorize our training data, vectorize our label data. Then we create our validation data. So here we are pulling out one fold to be the validation data. And then here we combine all the remaining folds to be the training data. And these are comprised of randomized samples each time. Similar with the testing data here. Then we use our build model function to build the model. Then we train the model. And then we evaluate the model. Then we append our score to the score list. We use matplotlib to show the training and validation loss here. And after all four folds are complete, we get an average of the validation loss to see how our model performed overall. And then here, what the matplotlib graphs look like. Very pretty. And then at the very end here, we test how our model does on the test data. Okay, over to the Newswire scripts. These are very similar, so I won't spend as much time on it. We load the training and test data here. Because on this one, we're sorting between 46 different topics instead of either labeling it as one or the other. We need to one-hot encode our label data, which is, we have an additional function to do that here. And also for our build model, our final activation layer is a softmax activation as opposed to, I believe, sigmoid, which was for this one, which is a binary right there. Yeah, sigmoid. Okay. But it still does all the same, processes 4K folds, creates validation data, all that good stuff. Onto our results. So description problem one, we want to classify the movie reviews either positive or negative. Using fourfold cross-validation, we'll select a model. We want to tune 3 specific hyperparameters for a total of 8 different points to test. So we had 3 different hidden layers to test. We had 3 different learning rates to test. And we had 2 sizes of training data words, either 1,000 words or 10,000 words. And we wanted to select the top 3 best performing models based on mean validation loss. And here are the steps that we did. I've already gone through that. And in summary, these were the 3 best models I was able to create. Excuse me. We had 4 layers in our top performing model, fairly low learning rate at 0.00001. Each of my 3 best models had 10,000 words in it. The accuracies were around 89%, and the top 2 models had a good amount of epics at 120 and 170, whereas the last one was a fairly small model with only one layer, a lower learning rate, and 10 epochs. And so I've included graphs of each of the k-folds for training and validation loss just to show my work here. And then I have this slide to show how I selected the epochs. You can see here, this is an example of overfitting. So I would have stopped it right here, here at figure 6.1, around epoch 200. That's where the validation loss is at a minimum. Um, that's how I've selected each of these models here. So I just wanted to be transparent about that. Okay, the evaluated performance of problem one. Each of the models had a test accuracy of around 88%, which is slightly lower than our validation accuracy, but that's expected. That's just illustrative of overfitting. We've memorized our training data a bit. And overall, I would suggest going with Model 3 just because it's so much simpler than the other two, and it doesn't perform that much worse. But of course, if that accuracy is really important, then I guess you wouldn't want to make that trade-off. Okay. Oh, one last thing about problem one, just a phenomenon I noticed. I thought it was pretty cool. The 1,000 word models help prevent overfitting. You can see that in comparing figure 10.1 to figure 10.3. The overfitting is much less noticeable in the long run. However, the peak accuracies for the 1,000 word models were marginally lower. They usually capped out around 85%, whereas the 10,000 word models could get to 88%, 89%. I thought that was neat and wanted to include that in my slide here. Final slide here for problem one is just total results of all 18 tests that I did and the best model accuracies, or validation loss accuracies, I should say. Okay. Mm, here's a description for problem two. So we wanted to classify the Newswire stories between 46 different categories using fourfold cross-validation. We wanted to tune I chose to tune three different hyperparameters uh, over 12 different points. So I chose six different hidden layers, four different learning rates, and then two different amounts of words in the training data, either 10,000 or 1,000. Similar steps as problem one, except we had that extra one to one hot encode the label data. And in summary, the three best models I created are here. Achieved around 81% accuracy on the models. The top model here, or all the models were fairly small with one or two layers, fairly low learning rates, around 0.001 or 0.0001. They all had 10,000 words in the training data, and the epochs range between 14 and 95. Um, I'll skip these. This is just to demonstrate my work. Okay, evaluate performance on problem two. So I was able, these models achieved about 79% accuracy on the test data. Um, there's no one model that was much better than the other. So you can't say one, really outperforms any of the others. But in general, it's best to have very few layers in these models for this problem. 10,000 words and a fairly low learning rate around 0.001 or 0.0001. And the homework also asked us to display underfitting, overfitting, and good generalization. So uh, throughout my experiments, I found examples that I wanted to include. So over here is underfitting. You can see that the validation loss hasn't quite started to drop off yet, so there's still room for improvement. So we should run it for more epochs. Here, you can see our model is definitely starting to just memorize the training data, and we should stop it now. It's not getting any better. And here is a good middle ground between the two of good generalization, where it hasn't memorized the training data quite yet, but the validation accuracy isn't starting to drop off either. Um, okay, and here are the total results for all of my tests, all 48 of them. So that is all. Thank you.